Welcome to our show, Cosmic Architecture, Mapping the Universe's Design, Part 1 of 2. Since the dawn of history, humans on Earth have looked up at the vast blue sky in wonder, and the cosmos fascinates us for good reason. When humans first appeared about 2 million years ago, Earth had already been evolving for 4.6 billion years. And when Earth itself was born, the universe had already existed for over 9 billion years. Before our sun ignited, hundreds of billions of stars had already shone across the Milky Way. It is no wonder we feel that the cosmos holds the secrets of creation, of the universe, of life, and of ourselves. Today, with astonishing advances in space science and technology, we're closer than ever to exploring these mysteries. Yet, each new discovery seems to unlock even deeper questions, some never asked before. Start with the obvious. Space is huge. Really huge. Our own Milky Way spans about 100,000 light years and contains billions of stars. And it's just one of trillions of galaxies. Just last year, the Siena Galaxy Atlas compiled data from scientists and amateur astronomers to map more than 380,000 nearby galaxies. Meanwhile, the Euclid Space Telescope recently captured images of over 26 million galaxies in a single view. And then come the cosmic giants, structures too massive to wrap our head around. We now know the universe is laced with vast formations, galaxies, superclusters, walls of stars spanning hundreds of millions of light years, and enormous voids still waiting for explanation.
These are brand new images from the Euclid Space Telescope, alongside gorgeous deep-field images of space that each contain millions of galaxies. We have a menagerie of strong gravitational lenses, including some special edge-on lenses, and even some double lenses. We have an entire zoo of galaxies coming in all shapes, sizes, and orientations.
And yet, beyond what we can glimpse, theoretical models suggest there's far more out there. Some estimates propose that between 6 and 20 trillion galaxies may exist across the cosmos. Of all this, we still know surprisingly little. Even more astonishing, scientists say all the stars, planets, and galaxies we can observe make up just 5% of the universe. The remaining 95%, composed of mysterious dark matter and dark energy, remains largely unknown. It's a humbling reminder of how much of the universe still lies beyond our understanding.
There are these things, there's dark matter you might have heard about. So dark matter is responsible for 85% of the gravity in the universe, and we have no idea what it is, but we can measure it. There's dark energy responsible for the accelerated expansion of the universe. We can measure that, but we don't know what's causing it. And then you add up all what these forces are doing in the universe, it's 96% of what's driving the universe. And all the forces of nature that we know and love, gravity, electromagnetism, the strong and weak nuclear forces, life, chemistry, biology, physics, that's in 4% of the universe. So we know enough about the universe to quantify our ignorance.
Dr. Jason Rhodes from NASA Jet Propulsion Laboratory describes the universe using a pie chart.
You can see that the contents of the universe are divided up into very uneven pieces. The stars here only make up about 1% of the universe. There's a lot more gas in the universe than that. That's a few percent. So we think that those 10 billion trillion stars in the universe probably each have at least one planet. The other piece of what we call normal matter is neutrinos. Neutrinos are small, ghostly particles, billions of which pass through you every second, but you can't feel them. But we know they're there. But all the stuff I've talked about is what we call normal matter. It's the stuff we can see in the universe. It's the stuff we can detect. It's the stuff that we see with telescopes in our eyes. It's you and me. That only makes up about 5% of the universe. And we've known for the better part of a century now that most of the matter in the universe is dark matter. It's a ghostly form of matter that's not giving off light. It's not absorbing light, and that's why we call it dark matter. The dark matter isn't even the biggest component of the universe. There's a bigger component of the universe that we call dark energy.
We can't see it, we don't fully understand it, but we know it's out there and is hugely powerful.
Science tells us that the universe is shaped by two fundamental forces, gravity and expansion. Gravity pulls matter together, forming stars and galaxies from tiny early clumps, while expansion stretches space apart. So where do dark matter and dark energy fit in? Dark matter works with gravity, holding structures together, while dark energy drives expansion, pushing everything apart. Dark matter is often called the cosmic glue because it helps gravity hold the universe together.
This image, taken with a space telescope called the Planck satellite, shows us the temperature of the universe in all directions. And what we see is that there were places that were a little bit hotter and denser than others. The spots in this image represent places where there was more or less mass in the early universe. Those spots got big because of gravity. If you don't have dark matter, those spots never get clumpy enough. It turns out you need at least 1 million times the mass of the sun in one dense region before you can start forming stars. And without dark matter, you never get enough stuff in one place. You wouldn't get our galaxy or any other galaxy. You wouldn't get the Milky Way. You wouldn't get the sun. You wouldn't get us.
Dark energy is a different story, and a strange one too. At first, expansion seemed to balance with gravity, but around 7 billion years after the Big Bang, the balance was lost. In 1998, astronomers were stunned to discover that the universe's expansion was speeding up. Gravity was no longer in full control. The mysterious force driving this acceleration is what we now call dark energy.
Many physicists were baffled. Why is the universe completely dominated by this mystery stuff? And it has seemingly bizarre properties. As the universe expands, matter and radiation thin out. Dark energy, however, appears to remain constant. This means that in the early universe, matter and radiation dominated, and the presence of dark energy had no impact. But about 5 billion years ago, the tables were turned. Matter had thinned out to the point where dark energy became dominant, and the acceleration of cosmic expansion began in earnest. This accelerated expansion dilutes matter even faster, meaning the future universe will be completely dominated by dark energy. In about 100 billion years, this expansion will have carried all galaxies outside of our local group beyond our cosmic horizon.
If dark energy carries negative pressure that thins out the universe, what causes it and where does it come from? Science has no answers so far, But in 2023, astronomers made a striking discovery. Dark energy appears to be linked to black holes. Two powerful cosmic mysteries now seem to be entwined.
A team of astronomers at the University of Hawaii, working in collaboration with astronomers across the UK and other countries, have found a connection between dark energy and black holes. The idea is these black holes might actually contain dark energy itself, and that this dark energy and the black holes are closely coupled to the expansion of the universe, and in fact that black holes might provide the answer to dark energy itself.
As we've seen today, the universe is a wondrous expanse, filled with astonishing structures and profound mysteries, from trillions of unseen galaxies to the elusive forces of dark matter and dark energy. Despite all our scientific advances, we've only begun to scratch the surface of understanding this vast cosmic design. Yet, perhaps these discoveries also invite us to reflect on our own precious place in the universe. By living with greater care, compassion, and humility, we honor the incredible creation that sustains us all. Our gratitude to the brilliant scientists, dedicated researchers, and to the wisdom of spiritual masters, saints, and sages who continue to expand our view of existence. May humanity cherish this gift of life on earth and walk more gently upon it, guided always by love and respect for all beings. Thank you, conscientious viewers, for joining us today for Cosmic Architecture, Mapping the Universe's Design, Part 1 of 2.